Hi and welcome to this video where we're going to be talking about how to calculate the pH of a weak acid or base. Now before you can follow into this, you really need to understand first off how to calculate the pH of a strong acid or base, and then also about what and how to write an expression for Ka or Kb and convert between Kas and Kbs. If you're not comfortable with that yet, please do go back over and revise the information in my previous videos, do some practice, look at some exam questions, whatever. But don't jump into this until you've mastered that content. Okay, so first off, when we have a weak acid, which has a small Ka, we have this expression. Okay, this is the expression that we're going to use to calculate our Ka. Now, if we have a pure solution of a weak acid, so all we've got is our weak acid and water, then we can make an assumption from this. We can assume that the concentration of our hydronium ion and the concentration of our anion, A-, will be equal. Because there's nothing else in that system, and it's a 1-to-1 ratio. This is obviously assuming we've got a monoprotic acid, but we're only going to be dealing with monoprotic acids in this standard. So you can make that assumption that the concentration of our hydronium ion and the concentration of our anion are equal. Therefore, we can simplify that expression down and solve it to find the concentration of H3O+, which is what we're going to need if we want to calculate pH. Now, I will reiterate, this only works, this simplification and assumption only works when we know that we have a pure solution. Okay, so don't just go blindly applying this equation to every time you have to do a calculation. Think about, is this assumption valid? Always. Now we can do the same thing for a weak base as well. So with a weak base, obviously we're going to assume that the Hb plus concentration and the OH minus concentration are equal, and therefore again we can simplify that down. So we can work out the concentration of our OH minus. From that we'll then need to calculate either the POH and then the pH, or the concentration of H3O plus and the pH. It's not uncommon to be given the Ka for the conjugate acid rather than the Kb for the base. So for example, let's say the base we're dealing with is ammonia. You might be given the Ka or pKa of ammonium NH4+. So you have to convert, if you're going to use this method, you have to convert that to a Kb. Now you can calculate the pH of a weak base using the Ka directly. And there are lots of methods in textbooks and in SciPads and everywhere else that show you how to do that. I don't do it that way. I much prefer using Kb. I know it's an extra step, but to me it helps me visualize what's happening in my system, and it makes logical sense to me, which is why I do it this way. If you're more happy using Ka, then please look at one of those methods and use that. Don't feel like you have to do it my way, but this is the way that I do it, which is the way that I'm going to demonstrate. There are other methods. Okay, so let's look at some examples. These are NCEA exam questions, I might add. Okay, so we have an ethanoic acid solution with an H3O plus concentration of 1.78 times 10 to the minus 3 mole per litre. And we've been asked to calculate the concentration of the acid solution. So we know what the hydronium ion concentration is, but we want to know what the ethanoic acid concentration was. So when somebody was mixing it up, how many moles of ethanoic acid did they put into 1 litre of water? We've been given a pKa for ethanoic acid. So, to start with, I'm going to turn that pKa into a Ka because I can't use pKa directly. So Ka is 10 to the negative pKa. Put the numbers in, and there's my Ka value, 1.74 times 10 to the minus 5. I'm going to write an equation, and I'm going to write out the Ka expression. No, I'm going to make that assumption first. We're going to assume that if the hydronium ion concentration is 1.78 times 10 to the minus 3 mole per litre, that the ethanoate ion concentration is going to be exactly the same. Right, so now I've got my Ka expression. All I need to do now is substitute my numbers in and then rearrange and solve. It's just an algebra problem at this stage. And so the concentration of ethanoic acid is 0.182 mole per litre. Please, whatever you do, show you're working clearly, use units where appropriate, write the equation, write the Ka expression every single time. Sometimes there is a mark just for putting that in, right? So please don't skimp on those things. You're working, and the steps you put in make it easy for the examiner to see exactly what you've done. If the examiner can see what you've done, even if you make a mistake, they can see where the mistake is, and so they can give you credit for the work you've done. If your working is all over the show, or you don't include it at all, then the examiner can't follow what you've done, and therefore can't give you credit for what understanding you've demonstrated. Okay, now here's a slightly more complicated one. When sodium ethanoate is dissolved in water, the resulting solution has a pH greater than 7 due to the production of hydroxide ions, as shown in the equation below. And here you've got a pKa and Ka for ethanoic acid. Calculate the pH of a 0.420 mole per litre sodium ethanoate solution. So, this is a base. You know it's a base because they've told you that you're producing hydroxide ions, and it's got a pH greater than 7, so it must be a base. Now, you can work this out from the Ka directly, but I'm going to go via Kb. But first I'm going to write my equation. So the first thing is when I take sodium ethanoate and I dissolve it in water, I get sodium ions and ethanoate ions. And that is a reaction that goes to completion because sodium salts are very soluble in water. The ethanoate then, so I know therefore that my concentration of ethanoate ions is 0.420 mole per litre. Right. Now, just going from the Ka and the pKa, I can work out the Kb, which is there. And I've got my equation for Kb. I should really write the equation for ethanoate reacting with water. Oh no, it's up there already. I get given that, that's right. So I can take that already. So, what do I know and what am I trying to find out? Well, I'm trying to find out the pH. This equation will give me OH minus. From OH minus I can then work out H3O plus and therefore pH. So, I'm going to make the assumption that the concentration of ethanoic acid and the concentration of hydroxide ions is going to be the same because it's a 1-to-1 ratio and we've just got a pure solution of sodium ethanoate. So I can simplify that equation and I can rearrange it and solve it to work out my OH minus concentration. At this point there are two ways you can go. You can convert your OH minus concentration to an H3O plus concentration, and from that you can calculate pH. My preferred option is to calculate pOH, which is the negative log of OH minus 4.81, and then calculate pH, 14 minus pOH, which gives me a pH of 9.19. Now, when you're doing this and you get your answer, always please stop and ask yourself, does this answer make sense? Is a pH of 9 a reasonable answer for the conjugate base of a weak acid? And hopefully you can see that yes, it is a sensible answer, because actually it's more than 7, which is what you would expect. You're told that it's going to be greater than 7, but it's not a lot greater than 7 because it is a very weak base. You can tell it because the pKb is 9.24, so it's a very weak base. Okay, so just one final little note. Quite often, as in the example just provided, there will be a salt. It might be ammonium chloride or sodium ethanoate or something similar, which you're asked. Now you need to be able to recognise that sodium ethanoate contains the ethanoate ion. The ethanoate ion is the conjugate base of ethanoic acid. Ammonium chloride contains the ammonium ion. The ammonium ion is the conjugate acid of ammonia, which is a weak base. So you have to be able to recognise those because they do pop up quite regularly. Okay, I hope you found this useful. I realise it's quite a lot to go through and you'll probably need to go and do some practice. But I hope to see you again soon. Thanks, bye.